Welcome back, everyone, and this is Math with Miss Santos. Okay, so this topic is adding and subtracting with decimals. So with this one, we are going to solve it algorithm-wise with decimals. We're going to prove it with a fraction, and we're going to prove it with a model. So model has to do with base 10 blocks. Okay, so for our first problem, we're going to do one addition and one subtraction. So this one is 3 and 5/10 plus 82 hundredths. How I say is also how I write the fraction. Okay, so first off, let's do the fraction. We rewrite the problem as a fraction also. We have 3 and 5/10 plus 82 hundredths. Okay, in the model, we start off with the first number, but we'll get to that afterwards, okay? So let's start with fractions. With fractions, the rules are to have common denominators, okay? So for here, we're going to multiply by 10, which makes it 3, and I'm going to use a different color for this, 50 hundredths plus 82 hundredths. So following the same rules of fractions, you add the fractions. This would make 132 hundredths and 3 wholes, which simplifies to 4 and 32 hundredths. And we're going to keep it like that because we're going to do decimals. So the denominator is going to stay 100. Okay, so this is 4 and 32 hundredths. So the way I said it will give us our answer, 4 and 32 hundredths. Now, let's go back to here with the decimal. We have 3 wholes and 5/10. Since we're adding the same kind of numbers, we're going to actually change that and add a 0 for hundredths. So 3 and 50 hundredths. So this is our placeholder. Now, when we added 50 and hundredths, we're going to do the 82 under the 50, making it 82 hundredths, which gives us that we're lining up the place values. Add them up. 0 plus 2 is 2. 5 plus 8 is 13. Carry the 1. And then 4. With the model, it's more simple to see. Okay, we have 1 whole and then 5/10. 1, 2, 3, 4, 5. For the second number, we have 8/10. 1, 2, 3, 4, 5, 6, 7, 8, and 2 hundredths. Since we have more tenths, this represents 1 whole. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This shows that we're going to give 1 whole to the whole. That's the same thing as over here. We gave 1 whole to the whole, which is from 10/10, and then we're left with 2 hundredths. We have 3/10 and a total of, oh, I messed up. Here's 3 wholes. My apologies. Total of 4 wholes. So you can see the connection, how all of these are the same. Now let's do it with subtraction. Split this up. Let's say we have 2 and 8/10 subtracted by 32 hundredths. We have 2 wholes and 8/10 and then 32 over 100. So same case scenario, we need common denominators. So times 10, which give us 2 and 80 hundredths subtracted by 32 hundredths. So over here, if we want to match it, we have 2 and 80 hundredths, because adding a 0 doesn't change the value of it, subtracted by 0.32. So as we can see, we have 80 minus 32. 80 minus 32 has to do with regrouping. Now, the regrouping will make sense with the model. So instead of actually solving, I'm going to show it with the model. So we start off with 2 wholes and 8/10. 1, 2, 3, 4, 5, 6, 7, 8. We don't have, oh, I forgot. Yeah, 8/10. It says to take away 3/10 and 2 hundredths. So we're going to start with the hundredths. There are no hundredths in this picture. So we're going to exchange one of the tenths to 10 hundredths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I could take 2 hundredths. So when we did that, exchange 1/10 to hundredths, that's the same thing as now we have, sorry. Now we have 7/10, and this 0 right here changes to 10 hundredths. So now we could do 10 minus 2 is 8, showing 8 hundredths. So for here, we have 7 minus 3. We could take away 3/10, so 1, 2, 3, leaving 4 tenths. And then 2 wholes. You can see it's like this. 80 minus 32. Okay, if you want to do a little math here, 32 plus 8 equals 40. And then plus 40 equals 80. Therefore, we have 48. This is 2 and 48 hundredths. There you have it.